Can you see me at all?
Yeah.
Hi, Hannah. We turned off the light so we can show you the answer key for the Greenie homework. So we just discussed it. So if you would grade your work and correct it, here are the answers. If you see 9 and 10, they're sideways on the side. 11, 12, 13, 14, 15, 16, 20, 25, 26. I think these are out of order, sorry. Because there's 27, 28. Then it goes to 21, A and B, 22, A and B, 23, 24. And then the ones on the back will finish it up. 38, 39, 40. Let me pan over there, get that large number. And 48. Okay. This answer key did match the numbers I assigned, didn't it?
I believe so.
Okay. All right. All right, Bailey, straighten up the camera again. Hannah, we are on page 165 in a comp book, and it's called probability. Oh, now it's got the disease. One thing, it's crooked here. All right.
I'm
You're
sorry,
making her
I told you my mother would never tell. Okay.
Okay.
Someone bumped the table.
Let's call it probability and just do a few definitions. Are you on a new page? 165. All right, probability. Let us define, there's certain words, and one of them is event, one of them is experiment, one of them is an outcome, and one of them is a sample space. The one I'll probably use the most is the last one, sample space, but I will define all four. So write down those definitions under the title probability, and we'll get those over with and jump into doing examples basically. So we need to know what an event is. It's a result of an experiment, which we have to define next. Result of an experiment. And what's an experiment then? An experiment we'll define is any happening which has an uncertain outcome, like rolling a die or flipping a coin. So happening with uncertain outcome. All right, well, what's an outcome? You see how these definitions depend on one another? Yep, and an outcome is sort of what its name implies. It's just a possible result. Like when you flip a coin, an outcome could be heads. And the sample space is the one that I'm most interested in. It's all possible results. All right. These words will explain themselves except for sample space. You'll understand them because of the sentences they'll be in. So I'm going to perform an experiment and I'm going to flip a coin. So what is the sample space? It is written with these nose things, the braces, and all the possible outcomes are written with a comma separating them. So the sample space for flipping a coin is heads, tails. All right, what's the sample space for one die, toss of a die, die toss? 1, 2, 3, 4, 5, 6. All right, let's get fancy now. What is the sample space for 2 dice tossed? What is the sample space there? So once you catch up on these notes, start listing the sample space for 2 dice. How many should be in there?
5.
Can you have a 1 in the sample space when you roll 2 die? Can you possibly get a 1? What's the lowest number?
2.
So you can get a 2. Can you get a 3?
Yeah.
4?
Yeah.
All right, where does it stop?
12.
All right, do you see how this is the only possible outcomes for the toss of 2 dice? Dice. All right, good. All right, let's actually then define probability and actually take some. Probability is a fraction. It's the probability of, it's the number of ways an event can occur, and it's sort of a counting thing, which is why we've been practicing, divided by the number of total possible ways. All right, I'll pause while you get that. Is that showing up in the board?
Yes.
Sometimes I go over to
There's
the
a
right.
little bit
I
of a
lose.
glare,
Well, okay.
but it's showing.
Let me see if. I don't think this will help because it's not sunny.
No, it's coming
Yeah,
from that light.
Yeah, we'll just turn that light off. Got a BB gun. All right. Do you have that down? Because I want to get rid of this stuff. I'm going to leave up probability. May I erase this? Do you have it? Abby? Allie? All right. All right, the definitions are not going to be very crucial, but this understanding how this works is. So let's do the probability, and this is how we write it, of tossing a coin and getting a tail. And that's read the probability of tails on one toss. And it says the probability is a fraction. On the numerator is the number of ways that event can occur. And when you're flipping a coin, there's only one way to get a head. A tail, head also. But how many total possibilities? Well, one is a head and a tail. So the probability of a tail on a fair coin is 1/2. So if you flip it 6 times, does that mean we're going to get 3 tails? Not necessarily, but if you flip it 1,000,000 times, will you get 500,000? You'll get very close. So the more events that you do, the closer the actual results will be to the mathematical probability. So when you go into life insurance, there are people called actuaries. They used to make gobs of money. It's one of the very practical uses for mathematics. They calculate those things because the insurance company doesn't make money if it doesn't know the probabilities of this happening or that happening. So, interesting field. All right, let us look at the probability of, on a fair die, of rolling a 1 with 1 die. So what's the probability? So this was a coin toss, this is a die, 1 die. So how many ways on a normal dice can you roll a 1? And how many ways possible?
6.
Alright, so the probability of rolling a 1 is 1/6. What's the probability of rolling a fair die and getting a 0?
0 over
There
6.
is no way you can get a 0, so 0 ways out of 6 total, which is 0. What's the probability of rolling a die and getting a 1, or a 2, or a 3, or a 4, or a 5, or a 6?
6 over 6?
Yeah, there's 6 ways to get that with the word or. So 6 over 6 is 1. So this example is impossible. This example always happens, so it shows you the lowest and the highest possible probabilities. Make a note of that. The probability of any event has to be between 0 and 1. 1 is totally, it must occur, and 0 is it cannot possibly occur. And all the other probabilities are the fractions or decimals in between.
What is that letter by P?
E, probability of an event. Probability of any event is gotta be between 0 and 1. Alright, so try this one. What's the